Today I picked up an IC test clip so I can do an easier job of probing the S74HC373. So you can see I've got the test clip here and my oscilloscope probes and ground leads connected to each of those. It's a lot less unwieldy than what I was trying to work with yesterday, where I had the little tiny test clips probing the individual IC leads on the dip itself. So you can see each of these, they go back to my scope here, and on that, what I'm looking at here on the scope screen, actually I'll turn on my iPod here because I've got the data sheet. I'm not sure if you can see this very well, but anyhow, so pin 1 is the output enable. That corresponds with what you see on channel 1. That's the yellow. Channel 2, I'm looking at what is pin 3, which is D0. That's the input for bit 0. And pin 2 is Q0, which is the output for pin 0. So that's what these two are. This channel 2 here is actually pin 11 on the IC. That's the Latch Enable signal. So what we're seeing here is Latch Enable is being asserted. That's an active high signal. The output enable is active low. So basically all the time the output enable is asserted. And what we see here is that on this channel 3 here, that's the input to the latch. That's coming from the ESP, which is this guy over here. There's 4 of these ESP chips, and those are the proprietary ENSONIQ DP chips that this thing really depends on. So from what I'm gathering here, it also has a DRAM controller in it. That means that there's not really any external support logic required to take care of the refresh responsibilities that you need to deal with DRAM. So the only thing that is external to this, to these ESPs, are 5 chips per ESP. So you've got this, the data latch, that's the 74HC373, and 4 of these DRAM chips, which are 4-bit by 64 kilobit or 64 kilobyte DRAMs. So that's what this is talking through. And you can see here again, that's just a single bit on the data line. Now with these four ICs, since they're 4 bits each, 2 ICs make an 8-bit byte, and we've got 4 of them, so that looks like we've got 2 bytes, which makes a 16-bit word. That this so the data bus that the ESP deals with is 16 bits wide. That's my assumption. I don't have any data sheets for this, and apparently there aren't. It's kind of even a bit more nebulous than dealing with the Synclavier stuff, where there's apparently not a lot of information available on the internet. So I'm just kind of having to piece things together based on what I can gather from looking at the physical layout of the circuit board, and I'm just using a bit of common sense about it. So going back to this, I've got it in free run mode right now. It's triggering on this signal. You can see if I shift the level up and down, it'll stop triggering and drop it back down again. So if I do a single shot capture, you can see here that's a fairly clean signal. You can see that got data coming in, and the latch enable says basically we've got a series of ones on the data bus that are coming in, being latched, and that's all being latched as a 1 on the output as well. But I'll do another couple samples here And notice some of these, I'm not sure if this is right or what, but it's starting to look kind of messy, the signals. For the most part, let's see if I can bring in a cursor here. I'll deal with that later, but there we go. Time cursor in here. So if you look at basically right here, see at the point where that input value is latched, the output tracks with it. This one here, where it's latched, drops down to 0, pops back up to 1 there. So this is still kind of messy looking. I'll take another shot here. Now, the other thing where, this is the interesting part, where the problem itself is with ESPB, which is channel 2 in the effects processor. So if I turn up channel 2 here, you can hear the white noise in the signal. By comparison, I've got effect number 49 here selected. If I turn up channel 4, here's something completely different. There's no noise in that signal, and whatever effect it is, it sounds very clean. And that's what this is supposed to sound like. So from this, because what I hear is fairly consistent white noise, there aren't any pops or glitches in it all or anything like that. My gut feeling is that there is one of the bits on this data bus is either sticking or there's something not right. I think it's just a single bit failure anyhow, and it's in one of two places. Either the data latch, where one of the inputs isn't being latched properly, or it's in the memory itself. I hope it's not the memory, because I'm able to find replacement memory chips, but I already have two replacement data latches, the 74EC373s. So if I have to replace anything that's failed, then I would hope that it's what I'm probing right now. But in any regard, though, my gut feeling, like I said, is that it's a single bit failure. Although, having said that, it could be that it is RAM. I would wonder if it's a single bit, that you might hear something more periodic and sound more like a tone than white noise, which is what we're hearing. So maybe it's not a single bit failure, and maybe it is something with the memory returning random values. But as my next step is, I've probed the first latch, and I have 7 more to do, and we'll look at those. Maybe I'll find one of the latches has really erratic behavior and clearly has failed, or maybe I'll see something along the lines where I look at the RAM chips to see if something weird's going on there.